Okay guys, so here we have our general form of polynomial equation, and now we're going to learn how to get leading coefficient, degree of the polynomial, and constant term of the polynomial. So here we have to first find out the highest power of x in this whole equation, and here we have n is our highest power of x compared to n minus 1 and minus 2, which means we have to look at this an times x raised to power n in order to get the leading coefficient. So leading coefficient, as the name states, the one that leads. In this case, that will be a n. Degree, as you can state, the degree is which is raised to power of something. And in this case, that is n. So in order to find the constant term, you just have to remember the constant term is the term that doesn't change no matter what the value of x is. In this case, that will be a of naught. We'll learn more once we do more examples. So our first example, f of x equals 3x minus 2. Higher degree of x is in expression 3x. So we use that expression to find the leading coefficient, the one that leads, that becomes 3. That is 3 in this case, so that becomes the leading coefficient. Our degree of the polynomial is x raised to power whatever that number is. In this case, that is 1. And our constant term that doesn't change no matter what the value of x is, negative 2 in this case. Sorry, I wrote positive 2 for some reason. And our second one is highest power of x is in expression x cubed. So our degree becomes 3, leading coefficient becomes 1, and our constant term that doesn't change becomes negative 1. And our third one's px equals 5. This one's a bit tricky because we don't have any x in the equation itself. You just have to remember x of 0 is always 1. So you can rewrite this as p of x equals 5 times x raised to power 0, which means our leading coefficient, the one that leads, is 5. Degree of polynomial is 0, since that's the highest degree of x. And our constant term is also 5, since it doesn't matter what the value of x is, it's always going to stay 5.